All right, so today we're going to talk about the domain and range of radical functions and just the domain of rationals, okay? So it's not going to be both for everything. It's domain and range for the radicals, just the domain for the rationals, but we'll talk about that as we get to it. The very first thing I want to remind you guys of, and remember, everything I'm doing we've already done, okay? So this isn't brand new content. We've spent time graphing these things before. So this is just a real quick review. So radical functions look like that, okay? And you should be able to notice a couple things that look familiar, right? Like A, we call it our amplitude, okay? So how big or small a graph can be, how fast it stretches up or down, that type of idea is based on your A term, okay? So the bigger the number of A, the faster the graph grows, okay? The smaller the number, so like if it's a fraction, it gets kind of flat. It doesn't grow very fast. But we also know that in this case, if A is positive, it's going to open up like this for this one. Okay? And if A is negative, it's going to open down like that. Okay? So that's what a radical function looks like, kind of like half a parabola that's opening sideways. Okay? So that's what your amplitude does. Then we have the h and the k. And we call that, we don't call it our vertex, we actually call it like our origin. Okay, that's where the graph starts. But if you want to, I'll put like in quotes here, vertex. If you want to think of it that way. That way you don't have to change your method of thinking for that. Okay? So A is our amplitude, HK is our origin. I'm not going to write down what H and K do because we should know, right? H moves it left and right, but it's the opposite of what it looks like. So if it's a minus H, you're going to move to the right. If it's a plus H, you're going to move to the left. K is your vertical movement, right? It goes up or down. If K is positive, it goes up. If K is negative, it goes down. All right? So we've already reviewed like the HK movements for so many times. We don't have to rewrite everything for that. So how are we going to use this for our problems? Well, first off, how do we find the domain and the range? So it's going to take us 3 steps. Okay? So whenever you have a radical function, we're going to take 3 steps. The first step is going to be to plot its origin. Okay, so the HK, figure out where the HK is, put a dot on your graph. Then step 2, draw the curve or sketch it. Like I said, we're not going to actually graph it. I just want to sketch it. And then step 3, we're going to use the graph to figure out the domain and range. Now, if you don't remember domain and range, domain is like the x values, like how far left does it go, how far right does it go. Range is your height, okay, your y values. How low does it go to how high does it go, okay? We always go from small to big in terms of numbers, right? So it depends on what our domain and range is, but you know, sometimes you might have to start at negative infinity and then to like 5 or something, because negative infinity is smaller. So with domain and range, we're going to want to find our origin. We're going to want to sketch it. And again, by sketch, I mean real lazy sketch. We're not going to do anything like perfect. And then we're going to use the graph to figure out the domain and range. Okay, so it is just 3 steps. And the 3 steps don't take very long. It might take you about a minute or less, depending on how fast you are at doing this. So don't think you're going to be spending a lot of time like finding all this information. Okay? So, here we go. All right? So we're going to identify the domain and the range. Remember, all these notes will be posted hopefully right after this class. I can upload the video and put them up there right away. But I'll try to put them up there as soon as possible. So we're going to identify the domain and the range. These are homework problems, just so you know. I think number 1 is, I think number 2 is not, but then the other 3 are. Okay? So this one is a homework problem. So identify the domain and the range. So the very first thing you want to do is you want to find your HK. All right? So for this problem right here, HK is what? What's my origin here? 1, -5, right? All right, cool. And my A term is positive, right? That way I know which way it's going to open. So since it's positive, I know it's opening up. Okay, above. So, all right, next, I'm going to draw a really lazy graph. Okay, so here you go. This is what I mean by a lazy graph. I'm not going to try to be too exact. Okay. I'm going to make a couple marks here, just so I have something to look at. And I'm going to put that dot. So 1, -5 is down here. Okay? And since A is positive, I'm just going to do this. I'm not even going to calculate anything. I'm just going to do the little line like that. Okay, the curve is going up and to the right. All right, now that I've done that, now I get to write down my domain and range. So domain. How far left is this graph? So when I look at it, how far to the left did it go? My x values. 1, right? How far right did it go? To positive infinity. Can it ever touch positive infinity? No, so that's going to be a parenthesis. But you do see a solid dot at 1, right? So closed from 1 to infinity. Okay? Sometimes you might see it on state tests like this. That's another way they might write it. So it just depends on what they want to show. All right, range. How low did it go? To -5. Now I know this one's a little bit more tricky, but how high? It's infinity. I know it looks like it's only going to like -1, but remember the graph keeps growing forever, right? So don't just trust your little picture. Think like, since it's a curve and there's a little arrowhead at the end, that means it keeps going. So it's going to be from -5 to infinity. Now the way you might see this on a state test would look like this. Notice how they use x and y, right? Because y is for height and x is for left and right distances. So you might see it like either way. So I'm just writing both for you guys. Okay? So that's not too bad, right? Notice you don't really need to do anything with the 4 in the front other than know it's positive. Okay? But I don't have to graph it properly or anything. We're just trying to find domain and range. Just a real quick sketch work. All right? So here's another one. Well, actually, let me put a box around this just so people know this is the answer. All right? So here's the next one. Now, I know this one looks kind of weird, so you're going to want to maybe rewrite it. So I'm going to rewrite it like this. There is one problem like this on your homework. That's why I did one like this. Just so that when you guys get it, you know what to do. So I'm just going to rewrite it first. You don't have to, but it kind of helps because you're used to these formulas looking a certain way. All right, so now I want to do the HK. I want to figure out my A term. Okay, so my HK and then my A term. So HK. What is HK? All right, -3, -1. And then my A term, well, I don't see it, but it is a positive one, right? It's in front of the square root. So A is positive. So again, I'm going to draw a really, quick sketch. I'm not trying to make it look too great, just something quick because I just need a picture so I can see what's going on. So -3, -1, my origin is right here. Oops, I'm sorry, wrong place. -3, -1, right here. And since A is positive, the graph has to grow like this. Again, I'm not calculating anything specific. I'm just sketching. Because you just need a sketch in order to find domain and range. So domain and range. So how far left does this go? -3. How far right? Positive infinity. Remember, they might write it like this. Range, how low? So -1. And how high? We're going to positive infinity again, right? So it might look like this. A lot of people get scared about doing domain and range because they always say, like, I don't know how to do it. But it's not too hard once you see a picture. And that's why I want you guys to do this. Now, there's another way you can do this without pictures. You can do it algebraically using formulas, okay? I always prefer seeing it because it's easier to say, oh, look, from here to here, right? So let me just list that. For me, I prefer the pictures, okay? So, and since radicals aren't that hard to sketch, let's just use pictures, okay? Any questions on the first two? Because right now we're going to move to rationals, which look a lot worse if you were to graph them, but thankfully I'm going to show you a way to do it without graphs. All right, so here we go. Rational functions. We did this as well. These are the functions that look like this. Don't draw this, by the way. They're the ones that look like that. But we don't need the picture. All you got to focus on is the denominator, okay? But rational functions look something like this. There's always some kind of fraction, maybe a plus k value, which moves it up or down. The minus h would move it left or right, okay? A could be positive or negative, which makes it like flip around. I think we did these type of things like 3 weeks ago, maybe 4 weeks ago. Because I remember giving you guys a quiz on that probably about a month ago or so. For most of the case, I think most of you guys did pretty well on this, if I remember correctly. The test wasn't too bad. All right, so HK is the center, okay? Now that's great. We're not going to need that information, but just so you know, it's the center. That's where the two asymptotes cross each other. I don't know if you guys remember that about these graphs. There's like asymptotes that are supposed to kind of cross each other, okay? So that's where it happens. Where that little dot is, you're going to draw a vertical line that's dashed, a horizontal line that's dashed, and you're not supposed to cross those lines, okay? But that's nothing we have to worry about for today, all right? And then A is still our amplitude. Now, if A is positive, I'll draw the graph right now. And if A is negative, so a positive would look like, sorry, drew it backwards, would look like this. Negative would look like this. Sorry, that's a little curling there. Let me fix that. But again, I'm not too worried about the graph. Not for this. Because all we're going to do is they're just going to ask you to find the domain of this. Just find the domain of this. So how do we just find domain? So here you go. So how to find just the domain for a rational function. So it takes 3 steps, just like the other one did, right? Number 1, set the denominator equal to 0. So you're going to find your fraction, whatever's in the bottom, you're going to set it equal to 0. Okay? And number 2, you're going to solve it. Once you set it equal to 0, solve it. By the way, you may have to factor. That might happen. So we're going to do a couple examples, some that do factor. And then 3, the answer, once you solve it, you're going to find an answer. So your answer should say, and this is what you're going to write, all real numbers such that x cannot be, and then whatever answer you got. If it was 7, x can't be 7. If it was 8, x can't be 8. If it was 0, x can't be 0. All right, so you're going to solve whatever answer you got. Let's say it's negative 3. Your answer should say all real numbers such that x cannot equal to negative 3. So you're just filling in that green part, but you're going to write that whole thing in quotes. Okay? If you want a shortcut, I guess you can just write this. Real numbers such that x cannot equal to, and then, I mean, you can do it that way too. You give me whatever number it happens to be right here. Because this vertical line means such that. So, and this means all real numbers. So all real numbers such that x cannot equal to. That's a real quick shortcut. In math, a lot of times we write sentences like this is the set of all x's such that, like, this is a full-on sentence, right? So in math we use a lot of things. Sometimes we'll use like backwards e. That means like some of them, right? The backward e means some of, not all of. So we use a lot of notation to write sentences in math. So you use a lot more in college. Here we don't do so much, but in college they do. All right, so find your denominator, set it equal to 0. Solve it, and then your answer should look something like that in quotes, okay? You don't have to write it in quotes, but I'm just saying use this stuff in quotes. And the green part, the solution, that's whatever you solve for. So here we go. We'll start easier and move on to a little more challenging. So if I want to find the domain, I'm going to get the denominator, which is x plus 7. And I'm going to set it equal to 0. That's step 1. Step 2, I'm going to solve it. Well, x is negative 7. And then I'm going to write the answer. All real numbers such that x cannot be negative 7. There's my answer. If you want to do shorthand for it, you can write all real numbers such that x cannot be negative 7. Either one is fine. There's so many different ways to write it. You choose. I prefer less writing, so for me, I would probably do the bottom. Questions on that one? Pretty easy, right? Not too bad. So let's look at that is a homework problem. Let's look at this one right here. You'll notice this one's missing a plus k or a minus k, but it doesn't matter because we're not focusing on that. Okay, we're just looking at the denominator. So let me just get the denominator and set it equal to 0. Remember, with all these fraction problems, if you're trying to figure out domains, just get the denominator, set it equal to 0. We may have to factor, so that's what I'm going to do here. Take out an x. I get x plus 2 equal to 0. And then I have to solve. So that means that either x equals 0 or x plus 2 equals 0. So my answer, well, x equals 0, that's one of them. That's already solved. The other one is x equals negative 2. So these are my two answers, right? Negative 2 and 0. I got two solutions. So to write my answer, remember, I'm not supposed to include my solutions. So it's going to look like this. All real numbers such that x cannot be negative 2 or 0. All right? That's what I want to write. All real numbers such that x cannot be my answers. Because if I let it equal to 0 or if I let it equal to negative 2, if I plug in a 0 into that equation, on top I get 4, on the bottom I get 0. You're not supposed to divide by 0, right? So 0 causes a problem. If I plug in a negative 2, I get 0 divided by 0. Again, that's a problem. I can't divide by 0. So I don't want to use these two numbers. They cause problems. Okay? If you want to write it shorthand, feel free. You could just write like all real numbers such that x cannot be -2 or 0. And that's okay. Let me fix this part right here. So here's the last one. Like I said, little by little, they can get a little bit more complicated. So this is going to be probably the most complicated type problem that you would see. I'm going to move this down a bit. Give me a second. It doesn't matter how complicated it looks. We're just trying to find the domain. And trying to find the domain, all that matters is the denominator. Okay? So just focus on the denominator for these rational functions. Now it's different for radicals. That one you got to find your HK and just kind of sketch it real quick. Here we're just looking at the denominator. So I'm going to get 2x squared plus 2x minus 12. I'm going to set it equal to 0. Notice I can factor out a 2 from all of that, right? Because there's a 2x squared, a 2x, and a 12. They can all be divided by 2. So let me take out a 2, just to make my factoring a little bit easier. So there you go. I took out a 2. The only thing left is the x squared plus x minus 6 inside. So I'm going to focus just on the inside of the parentheses, not parabola, sorry. Inside of the parentheses, just that part. Let me factor that. So a is 1, b is 1, c is -6. So that's going to be -6 and a 1. So I need two numbers that multiply to -6 that add up to a positive 1. One is positive, one is negative. A 2 and a what? A 3? Which one is positive, the 3 or the 2? The 3. Okay, so positive 3 and -2. Because 3 minus 2 is 1, that's good. And 3 times -2 is -6. So perfect. So I'm going to use those two numbers as my factors, okay? So it's going to be x plus 3, x minus 2, and then there's a 2 out here, equal to 0. Don't forget about that 2, okay? It's up here. We got to make sure we bring it back down. Now we're going to set everything equal to 0 like we have it, but by breaking it apart. So we're going to get 3 little pieces. 2 equals 0, x plus 3 equals 0, and x minus 2 equals 0. Well, 2 equals 0 is not possible, right? So I'm just going to put that's not possible. 2 cannot equal 0. The other answer, that's x equal to -3. And the third answer here, x equal to 2. So I have two solutions. X equal to -3 and 2. So to write my answer, I have to deny these answers, right? I got to say not equal to. So all real numbers such that x cannot equal to -3 and 2. That's my domain. Or if you want it shorthand, you can write it like this. Just so you guys know, the way that I did right there, shorthand, is super shorthand. Usually not written like that. The actual way it's supposed to look is supposed to look like this. This is the way it's supposed to look, but they make it acceptable to write it like this. But this is actually the green thing is the true, real, full sentence. But we're okay if you just use the big R there. It's okay. So are we okay with domain for that one? So just get the denominator, solve it. Whatever answers you get, don't use them, right? You're going to say x can't be that answer, all right? So I'm going to stop it here.